Hello, assalamu alaikum everybody. I hope each and everyone out there doing great and having good health. In this video, we're gonna explain another creative solutions from chapter mole of chemistry. See, two different vessels are there and two different solutions. So in solutions A, there are 400 ml 0.1 molar sodium carbonate are there, and in solution B, 250 ml 3.65 gram hydrochloric acid are there. So now the first question is, what is molar solution? So the molar solution is that when 1 mole solute dissolves in 1 liter solution, this is called 1 molar solution. So we know the question number 1. So number B is, what is the differences between the valency and oxidation number? I already explained these things in my previous videos, so I'm not going to explain it, because in this video series I'm just focusing on question number C and question number D. Think about the question number C is, determine the number of molecules of solute present in solution A. So you see in these questions, in this solution A, the volumes, molarity and the compounds are given. So what to do first? To determine the number of molecules, we need to find out the amount of mass of the solute in this solution. Now what are the data is given? You think the volume, that is V, is given 400 milliliter, okay, and the molarity is given 0.1 mole, and sodium carbonate, so we need to find out the molecular mass of sodium carbonate. You know, the relative molecular mass of sodium is 23 times 2 plus carbon is 12 plus oxygen is 16 times 3. So altogether this is 46, 12 and 48. So it would be 106. So this is the molecular mass of sodium carbonate. Now the question is, to determine the number of molecules, we need to find the mass of the sodium carbonate. So we know the rules is, or the principle is, W equals to SVM by 1000. So we know this, that W is equal to SVM. So we need to find out the value of W. So think about it. S is 0.1, V is 400 ml and M is 106. So if we divide by 1000, we will have 4.24 gram. Hopefully, if we say this, actually 0.1 times 400 times 106, and then if I divide, yes, it's actually 4.24 gram. So this amount of sodium carbonate is there in solution A. Now you think, in 106 gram is 1 mole sodium carbonate. In 1 mole sodium carbonate, there are 6.02 times 23 molecules are there. So if in 106 gram there are this amount of molecule from the rules of Avogadro, so in 4.24 gram the molecules would be 6.02 times 10 to the power 23 times 4.24 over 106. So we can do it times 6.02 over 10 to the power 23 divided by 106, and this is 2.408 times 10 to the power 22. So this amount of molecule are present in this solution. So we can say the answer is 2.408 times 10 over 22. So this is the answer of question C. Now the fourth question is, mathematically analyze the quantity of common salt that can be prepared by the mentioned reaction. So if you see this, these vessels and these vessels, they will react each other. So the reaction would be sodium carbonate plus HCl. So you see this should be equalized, so it should be 2 to produce 2 sodium chloride, 2 molecule of sodium chloride, then water and carbon dioxide. Now you think 2 molecule of sodium chloride is producing from 1 molecule of sodium carbonate and 2 molecule of hydrochloric acid. So when this type of questions in front of you, you must finalize which one is the limiting reactant. So you see this in this solution, there are 4.24 gram sodium carbonate are there, and in this solution 3.65 gram HCl is already given. So we not need to find out the molarity of solution B, because we know that this amount of sodium carbonate are there and this amount of HCl are there. Now you see from these equations we know that sodium carbonate is 106, and you see in hydrochloric acid this is actually 2 molecules. So there are like hydrogen 1, chlorine is 35.5 times 2. So this would be like 36.2. It should be 36.2 times 2, which is 73, I think. Okay, 36.5 actually. 36.5 times 2, which is 73. So now you see that 106 gram sodium carbonate is reacting with 73 gram hydrochloric acid. Now you think 4.24 gram will be reacting with 3.65 gram HCl. Now how to find the limiting reactant? So using this data, we can see that 106 gram sodium carbonate is reacting with 73 gram HCl. So 1 gram is 73 over 106. So this is 4.24 gram that will be reacting with 4.24. Now you think 73 times 4.24, that is divided by 106, which is 2.92 gram. So you see that 4.24 gram sodium carbonate will be reacting with 2.92 gram HCl, but here 3.65 gram HCl is already in this vessel. So we can see that sodium carbonate will be finished soon, first. So that is why this sodium carbonate is the limiting reactant, and then we need to consider this amount to finalize the production. So you see this 2 molecule of sodium chloride will be produced here. So they say mathematically analyze the quantity of common salt that can be prepared by the mentioned reaction. So from this equation we can see that sodium 23 plus 35.52. So you see here 23 plus 35.5 is 58.5 times 2, which is 117. So you can say that these 106 gram sodium carbonate will be used to prepare 117 gram sodium chloride. So we can say that 106 gram sodium carbonate, from these 117. So 117 gram sodium chloride will be produced. So mathematically analyze the quantity. So the quantity of common salt. So here 4.24. So as we know that from 106, 117 grams sodium chloride will be produced. So 4.24 gram sodium carbonate will produce 117 times 4.24 over 106. So we can say that 117 times 4.24 divided by 106, which is 4.68 gram. So 4.68 4.68 gram sodium chloride will be produced, because here is only 4.24 gram sodium carbonate. So from the reaction we see that 106 gram is the amount that will be finished first. So sodium carbonate is the limiting reactant. So 106 will producing 117. So 4.24 gram will produce 4.68 gram sodium chloride. So we can say that mathematically analyze the quantity of common salt that can be prepared by the mentioned reaction. We can say answer is 4.68 gram sodium chloride. So this is the answer. I hope you can solve this type of questions, because this is very interesting. When you solve this, try to find out the limiting reactant first. Otherwise, this one is your standard mark, you won't know. So thank you so very much for watching this video, and please let me know if you have any further queries and questions. I'm coming up with another video after that. Take care, stay well, bye.